My name is Jared Venema. I'm the COO of Frozen Mountain Software, and I'm here together with my brother, Anton Venema, our CTO, to talk to you about IceLink, a peer-to-peer SDK with a full WebRTC stack. Okay. When I first spoke to Dave, one of the organizers of this conference, I asked him what I should present for you guys tonight, and he told me that I should make sure that I show something working. Well, that's really hard to do with an SDK. I mean, what do you really show, right? I mean, an application that's doing WebRTC. Well, that's great. So I thought about it a little bit, and I talked to Anton, and I brought him along, and he's going to be working. So he's going to be beside me, and he's actually going to do some work for us tonight. So we're here to demonstrate IceLink, as I mentioned. It's an SDK for building peer-to-peer applications quickly, easily, and on all platforms. Okay? So to understand a little bit about IceLink, you need to kind of get into the history a little bit. About 2 years ago, we started working on a product that involved some peer-to-peer video conferencing capabilities. And what we quickly realized was there was really not a lot of good software out there for building these kind of technologies from the ground up. So we started looking to see if we could find something that would, include a turn server and a stun server and have an ICE implementation. And we said, you know what? If we really want to support all of these platforms, there's not a very, very good solution for that problem. There are a lot of pieces, but no comprehensive solution. So we decided to solve that problem by building our own SDK. As a company, Frozen Mountain has always focused heavily on providing software that developers can use to build stuff quickly and easily that solves business problems. So we'd already had a signaling library, WebSync, so we quickly started working on the peer-to-peer communication, ICE, stun, turn. In IceLink, you can find implementations of RTP, RTCP, SRTP, DTLS, STP, and so on and so forth. There's so many acronyms here, it'll give you a headache. What kind of developer wants to really get into the guts of those? 95% of you don't. There are 5% of you that do. That's fine, we're cool with that. But for the 95% of you that don't, we want you to be able to build an application without having to think about those kind of things. So we started realizing that maybe we needed to raise things up a notch. So we created what we called a conference API. The conference API does exactly what you expect. It lets you quickly and easily create a conference amongst one or more people, or two or more people, excuse me. So to really give you an idea how easy it is to build an application using IceLink, we're going to give you a 3-minute walkthrough of actually building an application here on stage, okay? Some of this code is already pre-built, but I'm going to walk through it with you. It's very simple. For you developers out there, quick pay attention because I think you'll like what you'll see. So our first step is setting up the stun turn server and starting up a signaling server. As mentioned previously, we're using WebSync for signaling, okay? But that can be whatever signaling server you want, XMPP, WebSockets, the choice is yours. We use WebSync because it has WebSockets built in and then it falls back in the older browsers. And we'll get into a little bit later why that's important. For our demo here, we're running in .NET, but this is available in .NET, Java, Objective-C. Pick your platform. We've written for all of them already. So once we've got the server components running, we're ready to start connecting peers. So step one, let's hook into our signaling server. Using WebSync, this connection is pretty straightforward. It's just a matter of creating a client and connecting to the server. Nice and simple. Step two is user media. This may look familiar to some of you guys who are in the intro to WebRTC. These steps are actually following very closely with what they described in those meetings this morning. Okay? So we've got our signaling session completed. We need to access the audio and video components of the current device. In IceLink, we've wrapped all that stuff up for you. You don't have to worry about what platform you're on and how they're going to access those devices and what they're going to return to you. We've put an API on top of it so that you don't have to worry about all that stuff. You just say, hey, I want to get some media, and it happens to be a video stream or an audio stream. Okay? So we're using platform-specific controls, but with a platform-independent API. The only differences you're going to see across our API are going to be nomenclature things because Objective-C doesn't support namespaces and things like that, okay? So once you've got access to the local media, displaying it is made incredibly simple through our layout manager. You pass the media you've created into the layout manager and let it take care of the rest. The next step is actually building the conference itself, okay? As I mentioned earlier, we have a conference API. It abstracts away all of these low-level concepts of what the peers are doing and how they're communicating and offer, answer, and all this jazz that you really don't have to care about 90% of the time, okay? There's no reason to worry about that when all you really want to do is create a conference. So we've abstracted that away and created this conference API. And all you need to do then is hook in some events to detect when those peer-to-peer streams are created and destroyed. So the final step is to signal the connections between the peers and bridge that signaling and conference API. So that way we know when people arrive and leave and want to create or destroy those peer-to-peer connections. We do this by bridging the signaling and conferencing APIs together through a couple of simple events that are built into the system. One thing you'll note with Icelink, throughout the entire SDK, everything is exposed through events. So you can add your own relays, you can add, or your own hooks into the relays, into the turn servers, into whatever low-level event you want to hook into. So if you really do need to get into that low-level API access and figure out exactly what was going on at that SDP level, you can. But we make it so you don't have to. All right. So at this point, we're pretty much ready to fire things up. So why don't we go ahead and try and launch one of these applications. We should have a nice little .NET video running here. OK, so that looks pretty good. So that's native .NET, right? And that's great. But of course, a lot of people want to run on mobile devices. So we want to take it a step further. OK, Anton will show you the code for this in just a moment here. But we're actually going to fire up an example that's running in iOS and Objective-C. So let's make an iPad communicate with .NET here. And we'll take a look briefly at the code that actually makes that happen. And I want you to note the similarities between the code that we wrote in .NET versus the code that we're writing right here in Objective-C. And you guys look fantastic out there. Look at that. You're beautiful. All right, Anton, why don't we take a quick look at the code for the Objective-C there. And I want you guys to notice that for some of you, this is gobbledygook, and that's OK. But for those of you who are developers, I want you to note that the API is the same. We have event hooks in here just like we did in .NET. The classes are named the same. Everything flows through. So once you've written it for one platform, it's very easy to take that knowledge and transfer it to another platform so that you're not feeling like you're relearning and relearning and relearning. OK, that's pretty cool. So the next step, though, is we really want to see this thing work on a web platform, right? So let's fire up Chrome and take a look at that. See how that looks here. We can communicate with Chrome for a second. All right. So there's Chrome talking with iOS. That's good, right? Everybody likes to see mobile devices talking with browsers, so you can have your various applications. Somebody's on the road. They can talk to somebody in the office. That's always a good thing. So now there's also always this underlying question with WebRTC. It's kind of the elephant in the room. Not a lot of people really talk about it heavily. And that is, what do you do with the legacy browsers? There's a lot of people who say, well, too bad. You've heard applications being built on Chrome only, right? Well, here's a WebRTC application running in IE. And that's full peer-to-peer, OK? We're doing a straight UDP connection. And we automatically pull in a Java applet that will take care of any underlying communications that are necessary for any browser that doesn't have native WebRTC support. So it'll use native if it's available. It gives you a fallback. And as I mentioned earlier, we're using WebSync for signaling. So even in browsers like older versions of IE that don't support WebSockets out of the box, you've still got long polling, and the signaling will still work. So you've got a comprehensive framework now that works across all of these devices. And you can develop with it to actually create real applications quickly and easily. As you saw, the amount of code that we've actually gone through here is probably about 100 lines of code. That's it. I'd also like to make a very short comment. I'm running out of time here, but I'd like to make a short comment about the great talk given to us earlier by the folks from Google. They mentioned that they were looking forward in 2014 to having a unified API across multiple platforms, and they wanted a way to make it easier to use WebRTC. That's what their goal is for next year. I'm here to tell you that's what we have for you this year. It's ready to go now. Let's start using it. Thank you. We're in booth 108. Come on by and check us out.